I'm Anil Kumar. Welcome to my series on test papers. Let me thank all my students for sharing their test papers and giving me this opportunity to make such videos. We are going to discuss a complete paper on trigonometry. This should be done without calculator. So let's see the type of questions in this test paper. You can always pause the video, copy the questions, solve, and then look into my suggestions. Question number 1 is to use trigonometric formulas to write a single sine and cosine function. Question number 2 and 3 are to sketch trigonometric functions. Question number 4 is to find equation of a sine curve from the graph. Question number 5 and 6, as you can see here, you need to find the expressions value, sine theta, secant 2 theta, tan 2 theta. The last question here is to determine exact value of cos of minus 7 pi by 12. Now we have some questions related to trigonometric equations. These should be solved within the given interval as discussed. Then question number 11, we are given cosecant A in quadrant 2, cos B in quadrant 4, and we need to determine the value of sine of A minus 2B. Question 12 and 13 are to prove trigonometric identities involving double angles. Perfect. So I hope you got a copy of these questions now. You can work on these questions as we take them one by one to solve. Now let us solve these questions one by one. Now in my solution, I'll also provide you with the formula and some explanation. So this video may be about 45 minutes long. Question number 1. Express as a single sine or cosine function A 1 over 4 sine theta by 2 cos theta by 2. We will use double angle formula, which is sine 2a equals to 2 sine a cos a, correct? In part B, we have 6 sine square 3 theta minus 3. We'll use the double angle formula relating cos 2a equals to 1 minus 2 sine square a, right? So these are the formulas which will be used. So let us see how to apply these formulas to get our result, right? So we are given 1 over 4 sine theta by 2 cos theta by 2. To get 2 times, we will actually write this as 1 over 8 times 2. So that is 1/4, correct? Of sine theta by 2 cos theta by 2. Now we can apply the double angle formula, correct? So think like this. It becomes simpler, right? So we have 1 over 8 sine twice this angle, right? So 2 times theta by 2. So that gives you 1 over 8 sine theta as the result. Perfect. So these are all the steps involved. Second, 6, let's rewrite the question. 6 sine square 3 theta minus 3. So we can take 3 common. So if I take 3 common, let me take first 3 common. Okay. So sine square 3 theta minus 1. But here you see 1 minus 2. I'm sorry, 2. 2 times, right? Because 3 times 2 is 6. So if I make it minus 3, then we get exactly how it is written here. Correct? So we get minus. I've taken common. So I could write this as 1 minus 2 sine square 3 theta. Correct? Now if you match, you can write this as minus 3 cos of twice this angle, which is 6 theta. So that is how you are going to solve the first question. Straightforward, direct application of a formula, right? So that is the result. So let's move on and take question number 2. You need to sketch minus 3 sine 2x minus pi on the interval minus pi by 2 to 3 pi. Now in such questions, you should actually first, let me write the equation given to us, which is minus 3 sine of 2x minus pi. So I can write this as minus 3 sine of 2 common, right? X minus pi by 2. So that really gives you the correct phase shift, right? Now here we know that the value of k is 2. So the time period t is 2 pi by 2, which is pi. Amplitude A is 3. Phase shift is pi by 2, right? Correct? And also this part is a reflection. So we have that minus is reflection on x-axis. That is to say that the graph will actually go like this. Do you see that? So it will go in the towards downwards. That is how the graph is going to be. Now I'm going to sketch this function in 2 steps. So let me just take this up here. Now, since the axis is along the x-axis, so the axis is y equals to 0, okay? So that's the axis. So we have a maximum value, let's say, which is 3, minus 3 is our minimum value. So I'm writing this. I mean, this is just a rough sketch since I don't have a graph paper here. This is minus 3, that is 0. Now, we need to sketch in the interval from minus pi by 2 to 3 pi. And since time period is pi, we are looking for 3 cycles, right? So that means 3 cycles. Correct? So let me sketch, since it is reflected on the x-axis, I'll first sketch 3 cycles going like this. So that's the first cycle. Okay, second cycle. This is the third cycle, right? So I'm just extending, correct? So that is how the graph of the function, this function which I have sketched here, is y equals to minus 3 sine 2x. So I have not incorporated the phase shift. You get my point. So in this particular case, if you see one time period is pi. So this is pi for me, second 2 pi. That is 3 pi, correct? So let's say somewhere here we have 4 pi. We need to sketch from pi by 2, and also we have a shift of pi by 2 to the right. So let me now incorporate the shift, and now I'm going to sketch y equals to minus 3 sine of 2x minus pi, correct? So I'm going to shift everything pi by 2 to the right. What is pi by 2 for me? So that is pi by 2, correct? So this is pi by 2. 1 pi by 2, 2 pi by 2, this is 3 pi by 2. 4 pi by 2, 5 pi by 2, 6 and 7 pi by 2. Correct? So what I'm trying to say here, that the whole graph will actually shift by pi by 2. So this point here, let's talk about zeros, will shift to that. Right? So this 0 is going to shift. So our graph will start from here. And then the minimum shifts by pi by 2, in between, right? Now this goes in between. And this 0 goes there. that 0 comes on this point, so this goes there. And so likewise, what we are going to do is shift each and every point by pi by 2, right? So all these minimums will come here. The zeros will move to the next 0, correct? So as you can see, we got all our points in place, and I can now sketch the graph of our sine function required. That's it. So the graph is from pi by 2 to 3 pi as shown here. Does it make sense to you? Correct? So that is simplest way of sketching the curves. So my suggestion here is always use 2 steps. So that is our step number 1, and this is the final step number 2, where we incorporate the phase shift, right? So here we have phase shift pi by 2, right? Perfect. So that is how you're going to do it. Now let's take up the next question, which is sketch the graph of y equals to absolute value of 1 plus 2 sine x on the interval minus pi by 2 to 2 pi. So I'd like you to pause the video, sketch this graph, and then look into my suggestions. Let us see how to sketch this function. So we'll again sketch it in 2 steps. First step will be y equals to, let me write this as 2 sine x plus 1. And the second step will be to sketch, let me not call this as y, okay, it's because y is our main function. Say y equals to absolute value of 2 sine x plus 1, correct? So first we'll just, let's say, call it a function g, which will be a simple sine graph, right? So let's sketch the sine function now. Now, the axis is 1, so that means the graph moves 1 unit up, right? So that is vertical 1 unit up, right? So let's do it like this. Then after that, we have maximum should be, amplitude is 2, so maximum will be 3, right? So let me just, so these are rough sketches, but they are fairly accurate, right? So we have this 2 amplitude, right? So maximum will be at 3, going down, minimum will be minus 1. Perfect. So that is the limit through which the graph will go. There is no phase shift in it. So we'll just sketch our graph, which is sine function, and we have to do in the interval minus pi by 2 to 2 pi. That means 2 cycles, right? So okay, so basically I have to go on this side also. So let me sketch kind of like this. I don't really have space here, but okay. So I'll make 2 cycles. Okay, so that is the graph for us where this is 0. Now, so one wave time period here is 2 pi, so that is 2 pi. Okay, so this much is pi by 2, this is pi for us. So the maximum and minimum will be at minus pi by 2. This is our first function, which is without absolute. Is that okay? Now we need to do absolute. So when you do absolute of a value, then the negative portion becomes positive. You get an idea. So it gets added on to the value, correct? Now what we have here is 3, this is minus 1, and that is plus 1 for us. This is 1 down, so it'll go 1 up. So let me sketch this with the red ink, different ink. Okay. So this portion here will be reflected. So when we do absolute function, right? So this portion will be reflected. So we have this as like this. Does it make sense to you? So that is what will happen to this portion. The positive portion will remain as such, and here again will reflect this, right? So this portion again gets reflected. Do you see that? So a reflection will be there in these negative portions. Correct? So the graph which we will have is, this is from minus pi by 2, right? So it will be kind of like this. Reflected like this, and that is the portion which is between minus pi by 2 to 2 pi. So we have one cycle here. Is that clear? Right? So that is how it should be drawn. Perfect? So let's move on and take the next question, which is question number 4. Write the cosine function for the following graph. Okay. So let's look into the time period of this particular graph. So we have a maximum here. Let me write down these values. This maximum is at 30 degrees, right? So I've not mentioned degrees, but let me write 30 degrees and 4. So we're going to use this point. And on this side, we have a minimum, which is at minus 30 degrees, and the value is minus 2. Perfect. Now, keeping that in view, I'd like you to pause the video and write the equation of this. We want cosine function. Perfect? Okay. So let's go with the axis. Axis will be maximum plus minimum, which is 4 plus minus 2 divided by 2. So that is 2 over 2, 1. So the axis of this graph is at 1. Okay? So that is the axis. Fine. From the axis, from 1 to 4, we get the amplitude, let's say just A. The amplitude here is 4 minus 1, which is 3. Now, as far as the cosine function is concerned, cosine function starts with a maximum. So, in our case, it is starting from 30. Therefore, the phase shift is 30 degrees, right? So 30 degrees right. So time period T is given to us between 30 to minus 30, and this is just half the wave. So it is 2 times 30 minus minus 30. So that gives you 60 times 2, 120 degrees, right? So the time period is 120. So therefore the value of K will be 360 degrees divided by 120 degrees, and that is 3 times. Now we can write cosine function. Y equals to the amplitude 3, and we want cosine. K is 3. X phase shift is 30 degrees, so minus 30 degrees. And we shift it up by 1 unit. Do you see that part? So that is how you get your equation. Perfect? So I hope the steps are absolutely clear. Let's move on and take question number 5. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 5. The line with equation y equals to 3 over 4x minus 1 makes an acute angle theta with the positive x-axis. Find the value of sine theta, secant 2 theta, and tan 2 theta. Let's try to understand the situation here. So we have a line which makes an angle. So it starts with minus 1. Slope is 3 over 4. So let me just draw a line like this, correct? So basically what we understand from here is that, well, this is minus 1. that at any point the slope is 3 over 4. Correct? So if I draw any angle, let me draw it here. Right? So in that case, the ratio of height to the base of this triangle is 3:4. We need not calculate x and y intercepts or things like this. Just sketch it, right? Y intercept is -1, you know it. So the angle which we are talking about, theta, is right there. Now in this particular triangle, 3 over 4, that means rise over run, right? Which clearly I have shown. So this side should be equal to 5, right? Right triangle. So it is 3 square plus 4 square square root, which is square root of 25. It has to be positive always. So 5, correct? So we can write down the value of sine theta as equal to 3 over 5. So that is part A. B, secant 2 theta. So secant 2 theta, let's do B here, which is secant 2 theta, or you could write this as 1 over cos 2 theta. Since we know what sine is, I could always write using the formula sec cos 2 theta, which we discussed earlier also, as 1 minus 2 sine square theta, correct? So that gives you 1 minus 2. Sine theta is 3 over 5, so we have 3 over 5 whole square. The calculator is not allowed, okay? That's kind of important. So which is 1 over, now this is 5 square, right? Which is 25. So we can write this as 25 minus 2 times, this is 9, right? So 18. Everything over 25, so I can take it up here. So it becomes 25, right? So like this. So that gives you the value as 25 over 25 minus 18, which is 7, right? So secant 2 theta is 25 over 7. Perfect. Now let's calculate what is tan 2 theta equals to. Now tan 2 theta, using the formula, right? So we have tan A plus tan B, so which is 2 tan theta over 1 minus tan A tan B, or tan square theta, correct? So from here, you know what is the value of tan theta. Tan theta is 3 over 4. This slope m, do you see that? So let's substitute this value here. So we get this as equals to twice 3 over 4 over 1 minus square of this. So I'm writing 9 over 16. Is it okay? Now, multiplying everything by 16, we get in the denominator 16 minus 9. And if I multiply numerator by 16, then 16 and 4, we get 4 here. 4 times 2, 8. 8 times 3, 24. You get it, right? So what we did was, we just times everything by 16, right? So 16 times 16 minus 9 comes in the denominator. Now here, we'll do 8 times 3, 24, and get our result, right? So we have 24 over 16 minus 10 is 6, but it is 9, so it'll be 7 again. So we get 24 over 7 as the value of tan 2 theta. So I hope you find this calculation simple enough, and that is how you could work with fractions and get your result without calculator. Okay? Question number 6. Determine exact value of cos of 7 minus 7 pi by 12. Now when you do cos of minus 7 pi by 12, you could do in different ways. So one method here is, which I like, think about it like this, minus 7 pi by 12. So if you are going in this direction, correct, you will land up somewhere here. That will be your minus 7 pi by 12, correct? Since this is minus 12 pi by 12. Perfect. So in that case, the beta, the related acute angle over here, is 7 and 5 gives you 12, so it is 5 pi by 12. Now, since we are talking about cosine of a value, and we know cos is positive here, all are positive, sine and tan is positive. So if I sketch it in the quadrant 1, a triangle with this angle here as 5 pi by 12, I could write this as, let me rewrite and show you. So I can write cos of minus 7 pi by 12 as equal to minus of cos of 5 pi by 12. Do you get the idea? So if you do all this, you could write in this fashion. Perfect? You could do that, right? So this is kind of, those who understand cofunctions and related acute angle, for them this should not be very difficult. Or you could also straight away write this particular function as cos of pi by 4 minus 5 pi by 6. Right? You could do that also. Or you could write this as cos of pi by 4 minus 5 pi by 6. So that will also give you what I'm trying to say. Perfect. But what I will do, I'll adopt this approach. So you could expand this and get your answer. But what I'm doing here is using related acute angle. Writing cos of minus 7 pi by 12 as equal to minus cos 5 pi by 12. Do you get the idea? So that is how I'm going to do. So we could write this as minus cos of, now 5 pi by 12 I have to break up. So I could break this up as 3 pi plus 2 pi by 12. So we are taking few steps here just to make you understand. So 3 pi by 12 means pi by 4, right? So it is pi by 4 plus 2 pi by 12 means pi by 6. And now we are going to use the cosine formula, which is cos A cos B minus sin A sin B. So it is cos of pi by 4 cos of pi by 6 minus sine of pi by 4 sine of pi by 6. Do you see that part? Now we'll use our special triangles. So that is one triangle and this is the other one. So in this triangle where we have pi by 6 as that angle, the sides are 1 to square root 3. The pi by 4 has, it's better to write 2 here and square root 2 and square root 2. So we don't have to rationalize. You get the idea. Well, we can also open this bracket. Multiplying by negative will give us a negative cos of pi by 4 times cos of pi by 6 plus sine of pi by 4 times sine of pi by 6. Correct? Now cos pi by 4 is square root 2 over 2. So we'll write this as minus square root 2 over 2. Sine, cos of pi by 6 is square root 3 over 2. Plus cosine square root 2 over 2. And cosine of pi by 6 is half. So as you can see here, 2 times 2, 4 is our common denominator, right? In the numerator, we have minus square root 2 times 3, 6. And here we get plus square root 2. So the answer is square root 2 minus square root 6 over 4. Perfect. So that is how we could solve this question. You could actually write it in this fashion, apply the formula and get same result. Is it okay? But remember, when you do 5 pi by 6, you are actually in this quadrant where sine is going to be positive, cosine will be negative. That is your answer. Question number 7. Solve 1 plus sine 2x minus 2 cos x equals to 1 when x is between minus pi to pi. Now here, let's rewrite this. We have 1 plus sine 2x minus cos 2x equals to 1. So that 1 and 1 cancels. So we have sine 2x minus 2 cos x. You could write 1 minus 1, which is 0. Now sine 2x can be written as 2 sine x cos x. And we have 2 cos x here equals to 0. 2 cos x can be taken as common. So we get sine x minus 1 equals to 0. So that gives us two possible solutions. One is that 2 cos x equals to 0. And the other one is sine x equals to 1. Then that will be 0. Okay? Now we have to work in the interval minus pi to pi. That is kind of important to understand. So if you sketch your graph for sine x, for example, so sine x is kind of this. So where from minus pi to plus pi, it is 1 at pi by 2, correct? As far as the cos x is concerned, this is sine x, right? So if you sketch cos x, you know cos x is 0 at pi by 2 plus minus pi by 2, correct? So you could sketch like this. Okay. So it is 0 at pi by 2 and at minus pi by 2. Correct? So these are the two values where cos x is equal to 0. So here we get the answer as x is equal to plus minus pi by 2, and here we get x equals to pi by 2. Okay? So our answer here is x equals to plus minus pi by 2. Okay? So that is how we are going to solve this question. Let's move on and take question number 8. We have 2 plus 2 sine square x minus equals to 3 minus cos x. This time we have to provide solution between 0 to 2 pi. Now, it is better to write sine square x as 1 minus cos square x and bring all the terms together. So we'll rewrite this as 2 plus 2 times 1 minus cos square x. Bringing 3 here because it's minus 3 plus cos x equals to 0. Right? So 2 minus 3 is minus 1, and let's open the bracket first and then we'll do. So here 2 plus 2 minus 2 cos square x minus 3 plus cos x equals to 0. 2 plus 2 is 4. 4 minus 3 is 1. So now we can write this as minus 2 cos square x plus cos x, and we have plus 1 equals to 0. I always like to keep this as positive, so I'll write this as 2 cos square x multiplying by negative, right? Then we will factor. So we need product of minus 2 and sum of minus 1. So let's factor. We get 2 cos square x. So we could write this as minus 2 cos x plus cos x minus 1 equals to 0. Taking 2 cos x common gives us cos x minus 1, plus we already have cos x minus 1 here. So we get our factor cos x minus 1 times 2 cos x plus 1 equals to 0. So that should give us, we need to now find solution between 0 to pi by 2. So that gives us two possibilities. One is cos x equals to 1, correct? and the other one is cos x equals to minus half, correct? So this one here, when equated to 0, gives cos x equals to 1, and this one equated to 0 gives cos x equals to minus half. And we need to find solution between 0 to 2 pi. So if you look into your cosine graph, which is between 0 to 2 pi, is kind of like this, right? So the two solutions, one is right at 0 and at 2 pi, right? So we get two solutions, 2 pi and 0 for 1. And for minus half, we also get two solutions. Correct? So which are those two solutions? Minus half. We could use special triangle 1 to square root 3. This is without calculators, correct? So this here, it is pi by 3, that gives you. And minus means that you are in quadrant 2 and 3, correct? So in quadrant 2 and 3, pi by 3 is your related acute angle, right? Pi by 3. So when that is the case, then the angle here is 2 pi by 3 and 4 pi by 3, correct? So those are the two angles. So one is 2 pi by 3 and the other one is 4 pi by 3, correct? So this is for half, and for 1 we already have x equals to 0 and 2 pi, correct? So we can now write down our answers, which is 0, 2 pi by 3, 4 pi by 3 and 2 pi as our solutions, correct? So I hope this is absolutely clear. Now let's move on and take the next question, which is 2 cosecant square x by 2 equals to 8, and this time it is from 0 to 4 pi. Okay, so we can write this as, let me rewrite, the cosecant square x by 2 equals to 8. So that means cosecant square x by 2 is equals to 8 over 2, which is 4. Now cosecant is 1 over sine, so I could write this as sine square x by 2 as 1 over 4, correct? So that means sine of x by 2 is equal to plus minus square root of 1 over 4, which is, let me write here, as plus minus 1 over 2, correct? Now another important thing to consider here is the domain. We are given the domain of x as between 0 to 4 pi, correct? So for x by 2, the domain will be, we have to divide both by 2, so we get 2 pi. You understand? So within 2 pi, we have to get all our solutions. Now let's look into the special triangle also, which is again pi by 3, pi by 6, 90, right? So pi by 6. Now 1 to square root 3. So we know that sine of pi by 6 is equal to half. Now we have 4 solutions. Plus minus means we are looking for pi by 6 in all these quadrants, correct? So that those are our solutions, correct? So as you can see here, we have x by 2 as equal to pi by 6, 5 pi by 6, correct? This is 6, this is 7 pi by 6, and this is 11 pi by 6, correct? So we have pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. So x is equal to, multiply them by 2. So we get pi by 3, 5 pi by 3, 7 pi by 3, and 11 pi by 3. Do you see how we found the solution? Right? That's a very good question. You have to work on the domain, right, like we did, to get all possible solutions. Perfect. Now let's move on. we have question number 10 here now. Question number 10 is sine square 2x equals to sine 2x. Now we have to work in the domain pi by 2 to 3 pi by 2, right? So let's see this domain here. We have 2x. Okay, so we are given x in between pi by 2 and 3 pi by 2. So 2x will be multiplied by 2, we get pi to 3 pi, correct? That is what our domain is. Okay, let's solve. So the equation here is sine square 2x equals to sine 2x. Let's bring them together. So we have sine square 2x minus sine 2x equals to 0. Now sine 2x is common. So we get sine 2x minus 1 equals to 0. So that gives you two possible solutions, right? So one factor here is sine 2x equals to 0. That gives, I will find the solutions. The other one here is that sine 2x equals to 1. Now we are looking into pi to 3 pi, right? So let's sketch the graph of sine function to get an idea. So we have, we'll sketch, okay. So in this graph, this is like 0. One full cycle is 2 pi and this is 3 pi for us, correct? That is pi for us. So between pi to 3 pi, we are looking for zeros. So the zeros are these points. Do you see that? So for 0, we get 2x equals to pi, 2 pi and 3 pi. So x is equals to pi by 2. This is pi and this is 3 pi by 2. Do you see that part? Now let us look into ones. So 1 is the maximum value, kind of this value, right? So these are the values for 1. So the only value between this is 2.5 pi, or you can say 2 pi by 2 plus half, right? So this is 3 pi. So we can say 1 pi by 2, 2 pi by 2, 3, 4, 5 pi by 2, right? So here sine 2x equals to 1 means 2x equals to 5 pi by 2, right? Or x is equals to 5 pi by 4. You get the idea. So that is how we are going to find the value of x from the second factor. So our answers are x equals to pi by 2, pi, 3 pi by 2 and 5 pi by 4, correct? So I hope this sketch here helps you to identify these solutions and also see that 2x should be between pi to whatever the angle is, between pi to 3 pi, right? So that is how you should actually try to find the answer. I would like you to pause the video, copy this question and then look into my suggestions. Question number 11. We are given cosecant A is equals to 4 over 3, where A is between pi by 2 and pi, and we are given cos B as equal to 5 by 6, where B is between 3 pi by 2 and 2 pi. Determine the exact value of sine A minus 2B. Now, when we say between pi by 2 and pi, that means this value is given to us in quadrant 2. On the other hand, B is given to us 3 pi by 2 to 2 pi in quadrant 4, correct? Now, when we say cosecant A is 4 over 3, that means sine A is equal to 3 over 4. So let's make our triangle here in this quadrant where 3 is the opposite side and 4 is your hypotenuse. So in that case, what is this side going to be? It is going to be 4 square minus 3 square square root, right? 16 minus 9, 16 minus 9, so let's do 16 minus 9 square root, and that gives you square root 7. So this side is square root of 7. The other, in this particular case, 5 by 6 will have 5 as your adjacent side, 6 as hypotenuse. So this side is 36 minus 5 square is 25 square root, which is square root of 11. Correct? Now sine A is 3 over 4. What is sine B equals to? Sine B has to be negative because we are in quadrant 4. So it is be negative square root 11 over 6. What about cos A? Cos A will be negative square root 7 over 4. Correct? So these are your values to work with. Now, let's find the expression, which is sine A minus 2b. So when I say we have to work for sine A minus 2b, that means sine A cos 2b minus cos A sine 2b. Now we can write these double angles in single angle, right? Sine A. Now cos 2b could be written as cos square A minus sine square A, right? So we could write this as cos square A minus sine square A. We could also, cos square B minus sine square B. So that is one way of writing. Okay, so let's write this. Cos 2b as cos square B minus sine square B. Okay, here we have cos A. Sine 2b is 2 times sine B cos B. Perfect. So let's now substitute the values. Sine A is 3 over 4. Cos square B. So this value given to us 25 over 36 minus sine square B. This is negative but becomes positive when you square it, right? So it becomes 11 over 36 minus cos A, which is minus square root 7 over 4 times 2 times sine B, which is again minus, so we'll write minus square root 11 over 6 times cos B, which is 5 over 6. 5 over 6, correct? So these are the values to work with. So we could take this on the right side and simplify this a bit. So we have 3 over 4 here. Within bracket, 36 is common. 25 minus 11 is 14. So we get 14 over 36. Okay. There are 3 negatives, so it remains negative. This could be simplified. We could divide this by 2, right? So 7 times 11 is 77, and then we have 5. So we have 5 square root of 77 over 6 times 6, 36 times 2, 72. 72. Correct? So this is what we get. Okay, so now we could simplify this further. 3 goes 12 times. Okay. And that is 7 and 2. So we have here 7 over 24 minus 5 square root 77 over 72. So 72 is a common factor 3 times. So we get 21 minus 5 square root 77 as our answer. Correct? So this particular expression, which is sine A minus 2b, should be equal to 21 minus 5 square root 77 over 72. Perfect. So that is how you could solve this particular question, right? Question number 12. Let's prove cos 4x equals to 8 cos to the power of 4x minus 8 cos square x plus 1. So let's begin with cos 4x. Now we'll use actually double angle formula, right? So cos 4x can be written as 2 times cos square 2x minus 1, correct? So the formula which we've used here is, let me write in this term, like cos 2a is equal to 2 cos square a minus 1. So that's the formula which we have applied. Now we can again apply the same formula for cos 2x, right? So we have 2 times, so here cos 2x can be written as 2 cos square a, which is x, x minus 1, right? Whole square, and then we have minus 1. Does it make sense to you? So what we did was, we substituted for cos 2x, 2 cos square x minus 1 whole square, that square, minus 1. Perfect. Now let's expand this, right? So when you expand this, in that case you get 2 times. Square of this gives you 4 cos to the power of 4x minus 2ab, that means 4 cos square x plus 1 minus 1. Let's open the bracket now. So 4 times 2 is 8 cos to the power of 4x minus 8 cos square x plus 2 minus 1. And that gives you 8 cos to the power of 4x minus 8 cos square x plus 1. Correct? So you get the right hand side as expected. So I hope that is absolutely clear. Right? We have one more question to go. Okay, here is question number 13, and this is definitely the last question to do. So I hope you're finding it interesting and useful. These are pretty good questions for your test. So at this time we need to prove that left side equals to right side, and left side is sine 2x over 1 plus cos 2x times cos x over 1 plus cos x. We need to show that this is equal to tan 2x. So we'll begin with the left side. Okay. Now, since this is 1 plus cos 2x, again the formula being used will be cos 2x equals to 2 cos square x minus 1, correct? Okay. So we could write this as, so sine 2x, let me write this as 2 sine x cos x. And the denominator, I'll write 1 plus 2 cos square x minus 1 times, we have cos x here, over 1 plus cos x. Okay. So plus and minus 1 cancel. So what we get here is 2 sine x cos x, rather square x when you multiply this, right, cos square x, over, here we have 2 cos square x times 1 plus cos x. Correct? So cos square x and cos square x cancels, 2 and 2 cancel. So we are left with sin x divided by 1 plus cos x. Now, how do we get tan x by 2 from here? Okay, so what we can do, again write sin x as 2 sin x by 2 over cos x by 2. Correct? And as we had cos 2x, we have 1 plus cos x. I could actually write this as 1 plus cos 2x equals to 2 cos square x. Do you see that? So 1 plus cos x can be written directly as 2 times cos square x by 2, right? So that is what I'm going to do. So I'm going to use the same formula which I used earlier in a different way, by after rearranging, right? So you understand this. And as you can see, we can cancel these terms. So what are we left with? We are left with sin x by 2 over cos x by 2, which is nothing but tan x by 2, the right side. Do you see that? So in this particular example, we have used the double angle formula of cosine twice to get our result. That brings us to the end finally. I hope you find this series very interesting and useful. Feel free to share it with your friends,
and I hope that helps. Thanks for watching and all the best.